Hello everyone. So previously we had discussed on the unbounded knapsack algorithm, right? So today we'll be discussing on the topic subset sum or the partition algorithm, right? So this one, let's get into the definition part. Let's see what the definition part say here. The subset sum problem is a classic dynamic programming problem. Yeah, the subset sum problem or the algo is a classic dynamic programming problem. It asks whether there exists a subset of given set of integers that adds up to the specific target sum. What it does, it asks whether there exists a subset of a given set of integers, that adds up to the specific target sum. So there should be target present as well, right? Target sum. So this is fine. Now, it forms the foundation of the partition problem where we check if an array can be divided into the two subsets with equal sum. Yeah, it forms the foundation of the partition problem. So recently we had solved the partition problem and this one, what do we call, uh, within the LeetCode, right? So if you remember, if you are following the things along with me, so you will be knowing that it forms the foundation of the partition problem where we check if the array can be divided into two subsets with equal sums. We have recently followed this one by making use of DP itself, if you remember. Right. So let's get into the definition part. Let's see what the let's get into the explanation part. So listen to this carefully. So we will be implementing the same thing whatever we discussed now in the form of algo or in the form of code actually. So here we are given an array, this one ARR, this one variable of size n and a sum target, right? What is our goal here? It is our goal is to determine if any subset of the array sums to the target or not. We have to split and we have to check whether it sums up to the target or not, right? That is our main goal actually. So it can be solved using the dynamic programming DP, where we will be making use of this one. First thing, this is very important. We'll be going with a or we'll be using a 2D DP Boolean table. Yeah. So we'll be making use of the 2D Boolean table DP of n plus 1 into DP of target plus 1, right? DP of ij, as we are making use of the 2D DP, so we will be going with the DP of ij that is equivalent to true. Means we can form some j using the first I elements, right? So let's see the transition logic here. See, if the current element, meaning this one array of I minus 1, if it is greater than j, then we cannot include it, right? So dp of ij is equivalent to the dp of I minus 1 j, current element previous one, right? So otherwise dp of ij is equivalent to the dp of I minus 1 j or dp of I minus 1 into j minus array of I minus 1, right? So this is fine. What are the base conditions? dp of 0, 0, this we will set this one to true. dp of I0 also will set this one to true. And dp of 0j will set this one to the false, right? So this is fine. Let's implement the same thing in the form of code, right? So by making use of the Python programming language, right? So just give me a second here. Yeah, first thing here, this one, we let's make use of the function is subset sum, right? So I'll just go with array comma target, right? So this is fine. So within this function, let me assign L equals length of array, equals length of array. So this is fine. The next step would be, let's go with the first step here. Let's create the DP table of the size n plus 1 into target plus 1. So this one will be DP of, let me go with false here. This is fine into, let me go with a target plus 1. So let me go with target plus 1, right? So this one will be for in range, mm, in the range, what shall I give here? In the range n plus 1, right? Yep. Now let's move on with the next step. So what did I do here? Something I messed up here. DP equals false. This is fine. Into target plus 1. This is also fine. And this is fine. For underscore. Or this one. Now this will be fine actually. Yep. Yeah. Now let's do one thing. We have successfully created a DP table of size n plus 1 into target plus 1. Next, let's go with the base case, man. What are the base case that we discussed, right? So base case is nothing but a sum of 0 is always possible, right? So this is nothing but the nothing for the this one for the empty subset actually. So I'll just go with for I in range. Let me go with n plus 1 actually. This is fine. So within this for loop, let me set the dp of I0, dp of I0 to the boolean value true. This is fine, man. The next step is so we have to fill the DP table, quite obviously, right? So we are almost at the end. We have to fill the DP table. That's the last step actually. And we have to fill the DP table and we have to return the answer, right? So let's fill the DP table. So this one will be for I in range uh, 1 to n plus 1. This is fine. So this is nothing but loop. We are just looping through the elements. So next for j in range, for j in range 1 comma target plus 1. So this is also fine. We are just looping through the target sums actually. So let's go with the if condition here. If array of I minus 1, if array of I minus 1, if it is less than or equal to j, equivalent to j, then what we will do, will either include the current element or we will exclude it. So I can just write it in this way. dp of ij equals dp of I minus 1. So this is what we discussed on the approach as well, right? Sorry, explanation part, right? So this one array of sorry, dp of I minus 1 into j minus this one actually I have to include array here. Array of I minus 1. This is fine. Or or I can just go with dp of this one I minus 1. dp of I minus 1 and j. dp of I minus 1 and j. Else what we will do, so we can't include the current element, right? So in for that purpose I can just write it in this way. For that case, sorry, I can just write it in this way. dp of ij equals, we cannot include the current element. I'll just go with a dp of I minus 1. Sorry, let me include this one. dp of I minus 1 j. This is fine. So we are done with the coding part almost. So we have to return the answer, nothing but the answer will be dp of n and target, right? So dp of n and target. So I'll just give here return dp of n and target, right? So this is fine, man. Yeah, now, so let's go with a simple example. So I'll just go with array equals here. So I'll just go with some random numbers, 34. Let me go with 4. Let me go with 12. Let me go with 5. Let me go with 2. Yeah. And target, let me go with 9. Target, let me go with a 9. And now let me go with the result equals is subset sum. This is fine. Let me pass array as well as the target. Let me pass array as well as the target. Right. So let's print something for the interactiveness. So I'll just go with a print here is subset with given some possible. Check the same. Let me pass the result. Yeah, this is fine, man. So this is it for the algo. We have considered the example usage, simple example I have considered here. So we know the algorithm. I have explained the algorithm step by step actually. Let me do one thing. If you want me to explain once again, so let me explain the algorithm once again so that we don't forget here, right? So each subset function, this is um, so, basically it consists of the parameters array and the target, right? So this function checks if any subset sums up to the target or not, right? So that is the reason we have made use of this function. Now we are initializing the DP table here, right? So we are initializing the what this one, sorry, DP table of size n plus 1 into target plus 1, target plus 1 and n plus 1, right? N plus 1 into target plus 1, where dp of ij is true if the subset sum j is possible with first I elements, right? First I elements. So we will be marking, or we have marked dp of I0 to true. We have marked dp of I0 to true, this part. So since sum 0 is always possible with an empty subset base case. We have discussed this one, right? So we should know this one. For each element array of I minus 1, so this one, for each element array of I minus 1, we decide if it is less than or equal to the current sum j, so that we have two choices. So either we can include it nothing but dp of I minus 1 into j minus array of I minus 1. Yeah. So this one I'm speaking of. Or we can exclude it nothing but dp of I minus 1 or dp of I minus 1 j. This one, this part or the this part, right? So this is fine. Otherwise we exclude it, so this part actually, else this part, right? So finally we return dp of n target, this one return, finally we return dp of n target, which tells whether the sum is achievable or not, right? So this is it for the all go. Actually we have considered the simple example here. See what is the output that we need to get here, accordingly with the example. Actually let's discuss the same actually. Yeah. Is subset with the given sum possible? Here in this case we are going with is subset with the given sum possible. We are printing the result we have to get here as true. Result we have to get here as true. Why we have to get true here? The subset, see here we have this one 334 4, sorry 334 4 12 5 2, and the target we have is 9 here. So we can just make use of 3 4 as well as the 2, 3 4 as well as the 2, right? So I'll just write here 4, 3, and 2. Same thing. I have written in a different order. That's it. 4, 3, 2, 3, 4, or 2, 3, 3, 4, and 2 actually. 3 plus 4 is 7, 7 plus 2 is 9, right? So when we sum up this one, will give the target. It'll sum to the target 9 actually. Therefore, the DP table finds the valid combination and the final answer will be quite obviously true actually, based on the algorithm that we have written, right? So this is the output that we need to get here. So let me delete this one, and yeah, let me run this one. Control J, give clear screen here, Python followed by the file name.py. So let me copy the entire file name here, file name.py, right? So here is subset with the given sum possible. The output that we are getting here is true. We are getting the desired output, right? So whatever the algo that we have written works absolutely correct, right? So this is fine. Now we are done with the algorithm part, man. We are done with the algorithm part, right? So we are done with the algorithm part. So before moving on with the next algo, so let me summarize whatever we have learned so far, right? So there are some 4 to 5 points which we have to remember at any cost. So I found it very this one important. So let's discuss the same thing. Let me summarize whatever we have learned so far, right? So here, uh, this one basically subset sum or the partition. It uses the concept dynamic programming, nothing but tabulation, right? Nothing but this one tabulation. Just remember this. This is very important, right? So the next step, next point here is, so this is used for use cases, right? So this is used for subset sum. This is used for the subset sum. This one, equal, partition, and the knapsack variants right? So this is used for subset sum, equal partition, and the knapsack variants. This is fine. So what will be the time complexity and the space complexity? The time complexity would lead to big O of n into target, right? The time complexity would lead to big O of n into target, and the space complexity would lead to big O of n into target as well. The space complexity would lead to big O of n into target. It can be optimized to big O of target as well. So it's fine. For the code that we have written, the time complexity would lead to big O of n into target, and the space complexity would lead to big O of n into target as well. Yeah. So what is the key idea here? So just build up smaller subproblems to reach the target sum using the dynamic programming. Build here small subproblems to reach the target sum using DP. So this is the idea basically. Yeah, these are some of the important points that I found very this one important, right? So we are done with a subset sum or partition algorithm, yeah, or the problem, however you call it, right? So this is fine, man. Yep, we are done with a subset sum or the partition problem or algorithm. Next we'll be discussing on the chain, this one coin change algorithm, or this one coin change algorithm or problem. So tomorrow we'll be discussing on the topic coin change problem or algorithm. Along with it, we'll be discussing rod cutting problem or algorithm as well. These two things. Yeah. For now, I hope the algorithm is completely clear. For now, this is it. Thanks for watching, guys.